For the network shown in the figure, we have to find out the rate of change of inductor current at the instant t equals to 0 plus. That is, IL of 0 minus is equals to IL of 0 plus. That is nothing but 2 amps. So V is equals to, after opening the switch, the current direction in the inductor is not going to change. So V is equals to 2 into 20, that is 40 volts. But here the voltage across the inductor is VL, that is VL plus V is equals to 0. VL is equals to minus V, that is minus 40 ohms, which is 4 DIL 0 plus by dt. DIL of 0 plus by dt is equals to minus 10 amps per second. That is, option B is correct. Consider a very lightly doped p-type semiconductor where P 4 greater than N is not valid. Then, using a Moss-Action law and the electric neutrality principle, the valid equation is. Here, electrical neutrality principle is nothing but a total positive charge is equals to negative charge. Number of holes and number of donor atoms is equals to number of electrons and number of acceptor impurities. Here this is very lightly doped p-type semiconductor, so Nd is equals to 0. P is equals to N plus Na. Now P is the majority carriers, N is the minority carriers. By using the Moss-Action law, we have to decide the minority carrier concentration. That means we know that Np is equals to Ni square is the Moss-Action law. Here P is the majority. We have to calculate minority carrier concentration by using Moss-Action law. So we have to replace P with N plus Na equals to Ni square, that is N square plus N into Na minus Ni square. So if we solve this quadratic equation, we will get N as minus, this is 1 by 2 minus Na plus or minus Na square minus 4 Ni square, which is option B is correct. In circuit, maximum reverse voltage across the diode is. So whenever the diode is reverse bias, this voltage is this and this is this. So reverse bias voltage across the diode is 2 into 24 root 2 minus 0.6, which is 67.282 volts, which is option B is correct. Figure shows a Zener diode regulator circuit whose Zener voltage is 24 volts and Zener resistance is 20 ohms. The power dissipated in the unknown resistor is. Here the power dissipated in the unknown resistor is nothing but current through the resistor and the voltage across the resistor. Voltage across the resistor Vx is nothing but 45 minus 24, which is equals to 21 volts. Current through the resistor is nothing but current through the Zener diode as well as the current through the load resistor. So Iz is given as 5 milliamps and IL is 24, that is 0.5 milliamps, that is 5.5 milliamps. So power dissipated across the resistor X is nothing but Vx into Ix, which is 21 into 5.5 milliwatts, which is nothing but here this is 2 milliamps, so this is 7, so this is 147 milliwatts. So option C is correct. State which of the following statements are correct. The inversion layer forms directly below the gate region, as it is true, and the threshold voltage is the voltage above which drain to source current flows. because threshold voltage is the voltage above which the channel is going to form, which is responsible for the current flow. So it's also a correct statement. When it comes to statement C, when the device is pinched off, the drain current remains approximately constant as VDS is increased. So whenever device is pinched off means it is entered into the saturation region. That means drain to source current is irrespective of the VDS voltage, it is a constant. So all the three statements are correct, hence the option D is correct. Here question is match the following. Given P, Q or S as germanium, silicon, Zener and tunnel diodes, and in other section we have properties belongs to these diodes. Zener diode is acts as a voltage regulator, hence P is 4. Silicon diode is having a reverse current is very low, so say Q is 2, that is P is 4, Q is 2. Comes to Zener diode, it is heavily doped as well as excellent conduction. Comes to Zener diode, it is a voltage regulator. Germanium, first one is P is germanium diode. Forward cut-in voltage is less, so is P is 3. Sorry. Now comes to Zener diode, R is, it acts as a voltage regulator, which is 4. So S comes to S. Tunnel diode, it is heavily doped as well as excellent conduction in reverse bias direction. That is option B is correct. A random variable Z which is equals to x plus y. Okay, the PDF of x is given as well as the PDF of y is given. So x can take 0 or 1 and y can take 0 or 1. So the number of levels taken by the Z is either it is 0, either it is 1, either it is 2. The probability of Z equals to 0 is going to happen when both are 0. That is probability of x and into probability of y, which is 1 by 8. Probability of Z equals to 1 is going to happen when either of the x or y is going to 1, that is 1 by 2, 3 by 4 plus 1 by 4 into 1 by 2, which is 3 by 8 plus 1 by 8. So it is 1 by 2, that is 4 by 8. Here the entropy is nothing but H of Z is equals to P summation log 2 of 1 by P. Here 1 by 8 log base 2 of 8 plus, here probability of Z equals to 2 is nothing but 1 by 2 into 3 by 4, which is equals to 3 by 8. This is 4 by 8 log 2 of, this is nothing but 1 by 2, this is 2, plus 3 by 8 log base 2 of 8 by 3, which is equals to 1.4 bits per symbol. So option C is correct.